Good morning, everyone. How many of you work in contact centres and wish you had access to accurate and timely data to enable you to better understand why your customers contact you? Don't you also wish that you could help your agents serve the customers who call you better by giving them timely data and insight into how better to interact with a customer? My name's Chris Ibbotson and I'm Principal Solutions Architect with AWS. And I work with our financial services customers to help them build on AWS to solve their business challenges. And I'm pleased to welcome you to session FSI316, how NatWest personalized customer experience with Amazon Connect and AI and machine learning. I'm privileged to be joined by two friends from NatWest, so Jill Beattie and Stephen Couch, who will, in this session, talk to you about who NatWest are and why they adopted Amazon Connect and the journey and architecture that has underpinned their adoption. They will talk through how they're making use of the rich data that Amazon Connect provides, both within the contact center operations, but equally within the wider bank as well. They will then touch on how they're leveraging artificial intelligence within Amazon Connect to both better serve their customers as well as their agent population. And finally, they will touch on what's coming next in their Amazon Connect journey. Let me now hand over to Jill, who will provide an introduction to NatWest.
Thank you, Chris, and good morning, everyone. Let me introduce you then to NatWest. So we are a FTSE 100 UK-based bank, and we support 19 million customers. And that's across our retail, commercial, and affluent business. And in fact, we're the largest UK bank for business customers. Now, like many organisations, our customers have adopted well to our digital channels, and we see 10 million daily logins into our mobile app, where customers will want to do their banking in our mobile app. But where customers are either struggling in the app, or perhaps they need that additional reassurance, or they have a complex query, that's where our contact centres play a key role. And we have 9 contact centres in NatWest, and they take 25 million calls on an annual basis. And they are supported by 9,000 agents that we have. And I'll just bring to life some of the examples of those calls that can come through. That can be customers who are concerned that they've got fraud on their account. Perhaps they are concerned that they've been scammed or have a payment that they want to dispute. It can also be customers who are in financial stress and they don't know how they're going to pay their mortgage next month and what help and support can we provide. Or it could be our business customers who have got large payments that they want to make and they want that reassurance that it's gone through. Or just other customers who are really struggling with the mobile app and want to do quite simple transactions. And it's those contact centres that we have migrated onto Amazon Connect. And let me just tell you a little bit at a high level on where we have been. So we started our journey onto Connect way back in 2019. And we were one of the first UK banks to pilot in our credit card centre. And perhaps like some of you, it takes an awful long time in NatWest to get our business case approval. And it wasn't until the end of 2022 that we actually got our full business case and a decision that we were going to migrate all of those 9 contact centres and all of those 9,000 agents for those 25 million calls onto Amazon Connect. So we formally stood the programme up in January 2023. And I'm really pleased to say that by the end of that year, we had migrated 66% of our agents onto Amazon Connect. And actually, some of them were our most complex contact centres. And then by October 2024, we had migrated all of our contact centres. And we've got now 9,702 agents onto Connect. So that took us 1 year and 10 months to do the full migration. And that was over 22 migration events. And we're now starting to do our decommission, which is a great place to be. And then we'll start on to optimization. But from a business perspective, there are some key benefits that we are really seeing from Amazon Connect. Firstly, it's all about the data and how you can use that rich data to improve both the customer and the agent experience. And we're going to talk about that and bring that to life and give you some examples of that later in the presentation. But also the speed to deliver has been fantastic. This year alone, we've implemented over 30 new self-serve journeys into our telephony estate. And we've been able to design, build, and deploy them in a matter of 3 weeks. Now, previously on our legacy platform, that would have taken about 6 months. And just the agility is fantastic. But also, the pay-as-you-go model really starts to change the mindset for the organization and really starts to get you to think about the optimization. Because as soon as we can improve that customer experience and either reduce the call or reduce the average handling time, the following month, you're starting to see the commercial benefits. And that was very different from where we used to be, where we were in fixed contracts and multi-year. And it's really starting to change the culture of how we think and how we really want to optimize. So let me bring on stage Stephen Couch, who is our platform lead, and he's going to take you through our journey in more detail.
Morning, ladies and gentlemen. So I'm going to talk to you a little bit this morning about the architecture that we've put in place for Connect at NatWest. And then I'm going to spend a little bit of time talking about the migration journey that we went on before moving on to how we're using the data and how we've architected that. And finally, a little bit about how we're using AI, specifically Amazon Q and Connect. I'm going to spend a little bit on this slide first. So I will be on this one for a few minutes just to give you a reasonable overview of what it is that we've got in place. So if you look at the left-hand side of the slide as you look at it, there's two primary ingress routes for calls into Connect for us. The vast majority of our customers still come to us over a traditional PSTN phone. However, and we have over 1,000 phone numbers across our various brands that we have feeding into that. The vast majority of which go into an automated self-service. Some of them go direct to agent, and also some of them do make outbound calls as well, particularly for things like fraud. However, recently we've delivered a new capability, which is the ability for calls to come into us using voice over IP directly from within our mobile app. So as Jill mentioned before, we have 10 million logons every day to our mobile app, so it's a key way of engaging with us for customers. This allows us to build, by bringing the calls into that route, this allows us to build seamless journeys that go from the mobile app directly into the contact center without the need for the customer to go move away and then dial a separate phone number. So to bring that to life as what an example might look like, say you're in the mobile app and you're trying to make a payment to one of your friends or a family member, and you're struggling to get the payment to go through. The first thing you would do is go to the built-in digital assistant, and that's an AI tool within the app that would help you try to figure out what your problem is. But actually, if that still doesn't work, you'd be presented with a button that simply says on it, tap to call. And you can click that button and connect it directly into Connect in the back end. And that comes in through the mobile platform over a series of lambdas and directly into the Connect service, putting you into, ideally, the right queue straight away. The really powerful thing about that is it also allows us to pass over details. For example, if you were facially biometric authenticated within the mobile app, we can pass the authentication token, meaning you don't have to then go through authentication again when you make it into the telephony journey. So whatever route the call comes in, once it lands in Connect, the orchestration is then managed by Connect from that point on. And the priority for us is to get the customer to the right person first time or as quickly as possible, even if when the customer phoned in, they didn't necessarily know what service they needed to resolve their problem. So we do this with a series of Lex bots that use NLCS, natural language call steering, to have proper conversations with the customer on the phone to figure out what it is that they're looking for. And actually, we have over 1,700 intents, so 1,700 different things that customers might call us about. So the way that works is the customer speaking. We pick up on utterances, the words that they say. We then map those to one of these intents. And then based on that, the Lexbot makes a decision about where to feed it into, which journey to feed the conversation into. Our priority really is to contain that call within the IVR. We don't really want customers having to talk to an agent because we know from experience that when they have to drop to an agent, it takes them longer. And actually, from our point of view, the operating cost is higher. It's much better for both parties if we can quickly get them the service they need automatically, and then they can get on with their day. But where we do need to drop a customer to an agent, we can do that. And that's usually for things, as Jill mentioned, power of attorney would be a good example, or a bereavement, something where it's a moment that matters, a fraud case, where you want the reassurance of a human being saying to you, it's going to be okay. So we've got the intent now, the customers come in. The next thing we need to do is make sure the customer really is who they say they are. And we do that primarily with voice biometric security. But first of all, we've got to figure out who they are. So the ID&V process, identity and verification process, that again uses a number of integration lambdas that you can see on the right-hand side of the screen within a VPC for security. They make calls to the back end and then use a new capability we've developed called call line identifier. So they know what number the customer is calling us from. So we can make back-end queries into our own banking systems, find out what accounts that number was registered against, and we can tell who the customer is without them having to tell us who they are, which is quite good. It saves them time, and it saves them having to remember a customer ID, which can be frustrating, especially if you don't call very often. We can do further disambiguation on that as well. So the Lexbots can also figure out, for example, where you've got a husband and wife that share a phone number, but they have separate accounts. Or where you've got multiple accounts mapped to the same number, up to query with the customer which account it is they want to talk to us about that day. In parallel to doing that, while they're still continuing to talk, we also make calls out to our third-party biometric service. So we're listening to the voice pattern of the customer as they're calling, and we're comparing that to the stored pattern that's registered against that account, and validating that it really is the right customer that's talking to us. And at the same time, we're also doing what we call bad voice. So we're comparing that voice to known fraudsters' voices, which the third-party provider has stored, to see if it's a known fraudster on the line. Or we're looking for inconsistencies in the quality of the line that might, for example, suggest that they're doing spoofing on the line. So these kind of things help us be sure that the customer is who they say they are. And all of this happens passively, and it all happens without the need to customer to enter their username or a PIN. And we treat all customers the same. So this isn't just a journey that we use in some cases. We don't care whether you're phoning up to make a £20 payment to your niece because it's her birthday, or whether you're one of our affluent customers that's phoning in to buy a new car. All of this process is exactly the same. So now we've got an intent, and we've got a positive ID, and we've verified who they are. So as I said before, ideally at this point, we want to keep them within the IVR. But we want to enrich that conversation now. So as they progress through the journey with the various things that they're trying to do, we continue to make back-end calls out through using Amazon SQS and the Lambda functionality to our back-end systems. And we're using that to pull back account information. What's their balance? What their account details? What's their address? Depending on what it is that they're coming in for. And we make all of those calls asynchronously. And we do that so that the conversation continues and flows. We're not waiting for the response to come back. The conversation just carries on naturally, which is a much better experience for the customer. And as we pull all that information back, we're storing it in a DynamoDB. We keep it there so that the customer doesn't have to provide the same information again, and so that we don't have to keep querying for the same information again. We store security tokens in there as well, but at the end of the call, when the customer is finished, all of that's deleted and the security tokens are shredded, ensuring that no data persists within the Connect service, keeping it all highly secure and keeping all the information on our own banking systems in the back end. Where a journey has had to drop out to an agent, as you can see in the bottom right-hand side of the slide there, we surface the call information in the Connect Contact Control Panel, CCP. And that allows us to surface all of the details of what the customer has already done and what they've already provided directly to the agent, again, without the agent then having to ask for it or having to ask the customer to be re-authenticated. And we do that either natively using the out-of-the-box CCP, or actually we found it quite easy to embed that CCP into our existing agent workspaces. So we have multiple different applications that are used across our business in the contact centers, and the CCP is embedded natively into that. So from the agent's point of view, it just feels like one application. They're not running a separate telephone service desktop application. It's all seamlessly integrated into one thing. Our workforce is largely remote, or at least hybrid, with a lot of them working from home at least 2 or 3 days a week. And actually they do that by connecting in over a Citrix session. So our desktops are all Citrix-based. The agents will be either using their own personal device or a thin client, and they'll be connecting in remotely to Citrix servers, and that's how they get to the applications. And one of the problems we had actually when we first delivered was call quality, or at least there was a perception of call quality problems. There was a perception that since we had migrated, the call quality had gone down. So what we've introduced recently is HDX. So this is Citrix's HDX component, allows you to hand off the processing of voice traffic outside of the Connect application. So when the agent is speaking, the traffic is passed off to another piece of software, another agent running on the local device. That then does the encryption and the encoding of the traffic. It then passes out the agent's own broadband connection over the internet direct to Connect. And that means it doesn't have to go into the Citrix servers within our service, and it doesn't need to transfer our existing internal network. And actually by doing that, we've seen a considerable improvement in the quality of the voice traffic. In fact, the number of calls that are called out now is being poor quality. So we use a MOS score, which some of you are familiar with, of less than 4 as being poor quality. That's less than 1% of calls now. And in the vast majority of those cases, when we explore them, they turn out to usually be the customer's mobile signal because they're in their car or they're in a poor signal area and nothing to do with the Connect service. I can see some of you nodding in the room. We're also finally using another tool which, for doing end-to-end monitoring, which we're just starting to experiment with now, a tool called Operator, which we're looking to use to try to monitor end-to-end traffic as it flows all the way through the journey, right down to the agent desktop. So rather than relying on a quality score that's based on the servers as it passes through, we're actually getting a quality score that's the agent experience in their ear on the ground. So we're working with that just now, and we're already seeing some good data coming through for that. So finally on this slide, that I wanted to touch on is a little bit about the data. So there's 2 places that we surface data in this architecture. Down the bottom, you can see wallboards. So in the old model, our wallboards were physical wall, as some of you may have had before, physical big screens in the contact center displaying how many calls are in the queue, how many agents are online. We've removed all of that. We now surface the wallboards as web pages on the agents' desktops. And that's proved to be quite useful. First of all, it's removed the cost of all that infrastructure, but more importantly, what it's allowed the agents to do is they can now change what queues they're looking at in the wallboards. So when they're transferring a call, they can advise the customer how long the wait is in the queue they're going to, or actually offer them a queued callback service so they don't have to wait on the line at all. The other place that we surface data is through QuickSight reports at the top and use Contact Lens for analysis. And we'll come on a little bit more to that later on, but that's about surfacing data that's used by the business for MI in order to allow them to make decisions about how the contact center is operating at a macro scale, but also for us as a technology team, where the optimizations are, which journeys we can improve, where people are breaking out of those journeys, and therefore how can we make those journeys better and more seamless for them. So I'll move on now just to talk a little bit about simplification. If I can get the slide to go forward. There we go. So one of the big things from a technology point of view that we've seen from the move to Connect is a much simplified architecture. Our previous architecture, which you can see on the screen just now, used a lot of best-in-class in their own area applications to provide an end-to-end service. It was a very distributed architecture with lots of different systems that required integration. So all of these, every application you can see there was a separate integration point, and some of them multiple integrations into multiple different systems. It also meant gathering the data was a lot harder because you had to not only integrate the applications, but you had to take all the data sets from those applications. They didn't always use exactly the same attributes and bring all that together in a meaningful way. It turned it largely into a data service, a data and analysis service, rather than something that could be done by the service users themselves. And the final challenge it presented was from support. A lot of you in the room will be technology providers, and you will know the challenges of having multiple applications talking when something goes wrong and trying to figure out which of the applications the problem lies with. So this was something that we were facing into every day. With our move to Amazon Connect, we were able to consolidate that architecture down, taking advantage of a number of the inbuilt capabilities within the service, such as speech analytics, call recordings, or NLCS, all out-of-the-box functionality that we now no longer needed a separate software provider for. And as we continue to experiment, we expect to make further gains as new features are being developed further. For example, the workforce management tooling and the agent desktop, which Amazon are working on just now and building out. These are things we're going to experiment with in the future to continue down that simplification path. The main benefits that we got from that, over and above the simplification itself and the data that I've already talked about, is something that Jill mentioned already, is the cost reduction. So actually, in the original architecture on the left, all of those were separate suppliers with separate contracts, many of them using traditional models of multi-year contracts where you signed up to hundreds of thousands or tens of thousands of licenses over long periods of time. But actually, now that a lot of those services are being delivered on Connect, what we can do is, as the call volumes go down, as customers choose to move into the digital channels more than the telephony channels, we now don't just make the saving from the actual call itself, we make the saving from all of the other services, because the consumption of those services also goes down. So if I move on to the migration, a big priority for us was to migrate safely. So as we mentioned a little bit earlier on, we have 9 contact centers, 19 million customers, and many of those contact centers operate on a 24/7 basis. So we always knew that doing a migration on this scale was going to be a challenge. Over the course of the approximate 2 years that Jill mentioned, we did 220 production releases into Connect to build out the service. And we also did a number of other things that you can see on the side there, 678 contact flows, 500 pieces of automation between the Landas and the Lexbots. There was a considerable amount of development that needed to be done to build out the service. But actually, the real problem was going to be how we cut over. So as you can see in the diagram, we were fortunate that sitting in front of our legacy service, at least, we had 2 telco providers. And actually, the way the telco providers work is that they face off a number of NGNs to customers, non-geographic numbers. So for the UK, that would be an 0800 free phone number that a customer would phone. But actually what they then do is translate that number into a direct dial number that actually talks to the legacy platform. And it turns out that's also how Connect works. So what we were able to do with the migration was build all of the target service, surface those direct dial numbers directly to the business, and allow them to do all of the checkout on those services while all the production traffic was actually still flowing through the legacy service. And then when it came to carry out the migrations, we could cut over on a number-by-number basis. So the migration events themselves became really simple. Instead of having to do a big release and a big code push at night and then have lots of people in doing checkout, actually for the migration events, we logged onto the telco console and changed the direct dial number that the 0800 number was pointing to. That was it. So the migrations were simple 20-minute, half-an-hour activity followed by an additional piece of business checkout for the business to be comfortable that everything was actually working on the day. And in many of the migration events, we took live calls from customers while we were still doing the checkout because we were that confident of the way it worked. And this gave the business a lot of confidence around how the service operated, how it ran, and how we were able to do the migration. And there's kind of 2 key points that we talk about that give away this confidence. Traditionally, as an organization, we've been quite risk-averse when it comes to doing big migration events. And normally what we would do is start small and ramp up. But actually with this, because we'd given the business so much confidence, we did our biggest contact center first. And that was really good, because what that did was it gave us a ton of data from that one migration that we could then use for all of the other migrations. The other thing we did, which is timely for this weekend, is we migrated our fraud department on the weekend before Black Friday, which, as I'm sure it is for many of you, is the busiest time of the year for us. We got a huge number of calls over Black Friday. So they were so confident that they were willing to let us do those decisions. And we only backed out one of the 22 migrations, and that turned out to have been a problem with a third-party system that was nothing to do with us. And as we were backing it out, the business were already helping us plan going a week later, which we did, and it went in successfully. So this gave us a really good and clean and safe way, low risk, to carry out the migration. There we go. So the other big decision we made around the migration was whether to migrate and optimize or migrate then optimize. And this is a dilemma that a lot of big transformation programs have. We wanted to move at pace, but we were also really conscious of wanting to make progress in our service. And how many programs have you worked on? How many big transformations have you worked on where you build a big business case, you have 2 years of development you're going to do afterwards, you've got these grand plans for what the service is going to look like, but actually the migration gets done, the funding gets cut, and you're gone. And we were really worried that that would happen here because we had big plans for what we wanted to do with Connect after we'd migrated over. In the end, the reason that we made the decision to migrate, then optimize, was simply down to data. So on our legacy platform, we didn't have any real meaningful data. But we knew we were going to get it once we moved to Connect. And we were really afraid that if we did the optimization at the same time as we did the migration, that we would make the wrong decisions. That we would make decisions based on how the contact centers think they operate, rather than what the evidence told us. So we followed this path instead of carrying out the migration. And then once we got it over, we started to experiment. We took a data-led approach. We ran experiments on different capabilities. And actually, this is where one of the strengths of that cost model and the way that Connect works came into power. We were able to turn on features and services within Connect, experiment with them for a few weeks, see whether or not our initial hypothesis as the value that they would add was any use, and then turn them back off. And you only actually got charged while they were running. You didn't have to go and do a deal with a provider based on a 3-year commitment just to be able to see whether or not the product actually did what it said it did. You can do so much in test, but you don't really know until you take it live. So that for us was a really powerful way that we were able to carry out that experimentation. I'm going to come on now to talk a little bit about data. Sorry, struggling to get these slides to move. There we go. So we've mentioned a few times that the big driver, one of the big drivers for us around moving to Connect was the ability to get access to data and the ability to use that data in a meaningful way. On our legacy platform, as I touched upon, all that data was dispersed across numbers of different applications. And actually, it wasn't really until all the applications fed into a central DNA function and we started to do complicated analysis that we could do anything at all really with that data. However, the great benefit of moving to Connect was that the data is now all in one place. However, that doesn't mean that you don't still have to do some work to derive meaningful insights from that data. So from Connect, what we were pulling out are 3 key things, really. We're pulling out the contact trace record, which gives you all the information about how the call happened and how it worked. We're pulling out the call transcription, so we transcribe all of our calls, which means we've got a text-based record of everything that was said by both the agent and the customer on the call. And we also capture the agent data. So there's an additional log that gives you details about what happened from the agent's point of view, who they were, how they acted, that kind of thing. And we fed those into what is a traditional ETL process, so export, transform, and load, that so many of you will be familiar with. And through that process, we use Lambdas to enrich the data. A couple of examples of that might be that where in a contact trace record, it would say who the agent's login ID was. We'd go away and query and bring in something more meaningful like what their actual name was. Or based on the number that the customers phoned us on, what brand are they? So we have multiple brands, and the numbers tend to be aligned to individual brands, so we know what brand the customer is. We then took that data, we started to structure it. We compressed it because we found that actually by compressing it, you got faster results when you come to do the reports later on. And we built a data dictionary around it, which allowed us to take individual attributes as Connect understands them, but give them names and turn them into things with metadata attached that the business could more easily understand. So rather than code-based attributes, turning them into meaningful descriptions of things. And an example of where we had to do this was abandoned calls. To bring this to life a little bit. Abandoned calls wasn't something that you could just query. You had to define from a business point of view what makes a call abandoned. How do you determine that the customer abandoned the call versus the call failed or actually something else happened? So we had to derive all that. Then we had to, in Athena, write a series of SQL queries that would bring together all these data points you'd agreed that made up an abandoned call, and then you can generate a report on what an abandoned call is, the abandoned call report, and surface that in QuickSight for the business to be able to use. Now that is a huge improvement on what we were doing before. As I said, we didn't have the data before. Now we had it all in one place, but it did require some technical development. So it was a faster process, but it was a largely technical process. And that meant that it was technical teams who had to understand how to write code, how to write SQL, but they also had to understand a little bit more about the business than they were used to understand what things would be meaningful data points to touch upon. So the frustration actually shifted from not having the data to knowing that they had the data, but actually it was a bit more difficult than they'd hoped to get access to. But the good news is that's changed again. So we're starting to experiment again with the new Amazon Connect Zero ETL data lake. And what you can see hopefully stands out in that slide is that big long piece of ETL that we had coded and written and developed ourselves, that's now done for you out of the box. So those same 3 bits of data are being pulled from Connect and fed into the data lake, but actually the data lake is now doing the work to figure out all the key touch points within that and to present that in a way that was meaningful. You still have to write Athena queries, so you've still got to do that, but they're much more simplified SQL queries. And this allowed us to move faster again, and it also allowed us to be more data-led in our decision because we could get to that faster. So take the abandoned calls example. That's now a data point that you can pick up. You don't need to determine what an abandoned call is. It's automatically there for you to query. We're also starting to experiment with new data points. The ones that are getting us quite excited just now are things like, what speed does the agent talk at? What speed does the customer talk at? How many times does the agent interrupt the customer? And as a result of those things, depending on the different combinations, does the sentiment that the customer have on the call increase or decrease? And Jill will talk a little bit about the importance of sentiment in a later slide. So this was a much less technical process. In actual fact, the other thing that we got from this is a drag and drop functionality. So whilst we still build business reports, they're much faster. They're days now instead of potentially weeks as they were on the previous model. But actually, there's a drag and drop, that's easier to say, functionality that you can now use to build custom ad hoc reports. And actually, you get a list of all the key metrics down one side, and you simply drag them in and build a table. And it's no more difficult than, for example, making a pivot table in Excel might be. It's a much simpler process for that ad hoc reporting. And our customer X-ray journey, which is the one I referred to before, we turned that around in days rather than in the weeks that it would normally take us. So I'm going to hand over to Jill now, and Jill's going to talk to you a little bit about what we're doing with that data.
Thank you. So I'm going to try and bring to life for you 3 examples of how we've used data across the organization. There we go, the slide did work. Before I do, I'm just going to explain how we used to do coaching in NatWest, and possibly like a few other contact centers. So we had team leaders who would go in, and they were responsible for a number of telephony agents. And through call listening, they would listen to a very small sample of calls and then determine your coaching needs. And that could be a good call or a bad call, but it was a very small sample. As Stephen mentioned, we now transcribe every single call. So we now have 25 million data points on an annual basis. And our first piece of work that we wanted to do was through sentiment analysis and see, could we drive up sentiment analysis through data-led coaching? So rather than spending the same time on every single agent, could we actually do some specific coaching for those agents who really needed it? Now, sentiment, if you're not familiar with it, every single call that is transcribed then has a sentiment score attached to it. And it listens to the words and identifies them either as positive, negative, or neutral. And you get a score for the customer, and also really quite interesting, you get a score for the agent as well. And what we wanted to do was start to see, through that data-led coaching, could we start to drive up the customer sentiment? Now, as we started to get into that, what we realized is you don't necessarily need to look at just all the negative sentiments. This was really about when the customer comes into the call, whatever their sentiment is at the beginning of that call, can the agent really help and make sure that that call is more positive towards the end? Or in fact, sometimes less negative, because customers can be coming in with quite a lot of financial distress. So we took one of our contact centers, actually one of our affluent, and did data-led coaching to see could we actually drive up the customer sentiment. And you can see on the screen we could by quite a significant volume. And also the agent sentiment went up, and of course it did, right? They wanted that data-led coaching. They wanted to be more confident on the call. One thing that was a pleasant surprise for us was we also saw a reduction in HT. And that's pretty helpful because we've talked a lot about the benefit is the pay-as-you-go model, so the financial benefits were starting to come through the following months, and yet we had also had happier customers and happier agents. So that's one piece that we're really focusing on. And I'm really pleased to say one of our business areas now has a target on customer sentiment. They don't really look at Net Promoter Score. This is a key data point for them. The second piece of work that we've been doing, again, that demonstrates the value of the data is hang-ups. Now, this is where customers are hanging up. And you can see we have quite a significant volume of hang-ups here. And we always knew this number. We knew this number on our legacy platform. But, you know, people would say, oh, that's just customers coming in really early in the journey, and maybe the doorbell goes and they're just distracted, so they hang up and it's all right because they call us back again and they'll have a really good experience. Well, now we could really get in and understand that data, and actually that assumption was completely wrong. We started to have a look at the timing, so were customers who were hanging up really early in the journey? And they weren't. We timed a sort of 10 seconds, 20 seconds, 30 seconds. And there wasn't much change in the data. It was 16% of customers in that hang-up phase were actually doing it in the short time. And as we started to get into the data, we could see some of the customers were almost in that vicious loop, which I'm sure some of us recognize, in IVR, that they could never actually get out of IVR. And they weren't hanging up, they were giving up and having a really negative customer experience. And what we found is they were trying to give us utterances that we could then get into intents, and we just didn't recognize them. So what we're now starting to do is take all of that data and improve our natural language call steering. A real insight for us starting to get into that level of data. And then the final example is some work that we've been doing on vulnerable customers. Now, when I talk about vulnerable customers in a banking term, that's just customers who need that additional support. And it can be anything that they have, physical ailments, mental ailments, or just something that is happening in that moment in their life. It could be a bereavement or a divorce, that they just need that additional support from us in the contact centres. And we built with Contact Lens lots of rules so we could identify, because all of those data points, we didn't want to be asking a customer, are you vulnerable? What on earth would that mean to a customer? How could we be really proactive, identify them and give them that additional support? And what we did is we took away our really experienced telephony agents and team leaders and said, here's all the intents that we identify, help us build that out. And they really started to help us, and we now run the data based on an increased intents that our kind of experienced agents have been helping us to do. And we now have a 4-fold increase in vulnerable customers. But again, a bit of a surprise out of the data, when we ran that, we were actually able to see that our agents were actually taking quite a lot of abuse from customers. And that enabled us to step in and do some additional coaching, but also explain to the agents of what's actually acceptable and what's not acceptable. And again, through the data, we could actually start to improve the coaching from that. So I really hope that that's brought to life just some of the examples that we are using from those 25 million data points that we have. And let me pass you back to Stephen, who's also going to explain some work that we've been doing with AI.
In there? No? Can you? No, not getting anything. There we go. Oh, there we go. Thank you. Okay, so I want to move on to Amazon Q and Connect in a second, but before that, I'm just going to talk a little bit about Lex chaining. And this relates to what Joe was talking about previously. So in our original design that we had for how we control the Lex interaction with the customer in the NLCS, we originally designed the solution with one single Lex bot. And actually, as I said at the beginning, and Jill's mentioned again, we have over 1,700 intents within the service. And what we found when we originally had that single bot model was that it wasn't performing at scale with that many intents. And what we were finding was we were getting a really low intent accuracy coming back from Lex. And actually, it was getting worse the more intents we added into it. The additional problem that we had with that was actually changing that bot was getting, from a code and a development point of view, really complicated. It was growing quite large, and it was meaning we had to do a lot of testing to actually make relatively simple things to be sure that we hadn't broken anything else that was already working. So instead, we reached out to Amazon, and they worked with us to come up with this idea of Lex chaining. And actually, at the time we did this, we think we were probably the first people to do this, with having Lex bots interacting with each other in this way. So on the flow that you can see there, customer is making utterances, so the thing that the customer says. That's being picked up by the bot, but instead of now trying to turn that into an intent against 1,700 intents, it only looks at 35 high-level intents. Once it's determined what that high-level intent is, it then passes it off to a child bot that's a specialist bot in that particular intent. So for example, if the customer is trying to make a payment, that's a high-level intent. That would then be passed off to a child bot who would then say, actually, the customer is trying to make a faster payment and they're trying to do it to someone that they've already got set up as a PAE. So you've broken down the intent and provided a much simpler, more modular architecture. Down the bottom, the other thing we did was through CloudWatch, we managed to start pulling NLCS logs. Because as Jill mentioned, a lot of our customers were saying things and we weren't understanding them. And actually asking the technology teams who weren't as familiar with the journeys to unpick that didn't seem like the sensible way to go. We wanted to let the business do that for themselves. But it turns out the customers rarely say what you think they're going to say. So a couple of examples of that might be, customer never phones up and says, what's my balance? Typically they'll phone up and say, how much money's in my account? So you've got to do that mapping. Or they would phone up and say, I've moved house, not change of address, which is what we call the intent, or what we call the journey. So we wanted to push that out to the business and let them do that. So we've introduced what we call our federated development model. So now the business take these NLCS reports that we've generated for them, and they determine what changes to make, and they actually write the code for it now as well. We support them when they need it, but largely they do it on their own, and then they bring the code back to us, which we then embed into our next release cycle, and we test for them, and then we release. And that's turned these NLCS changes into things that on the old platform took months, were done 2 or 3 times a year, to something that we now do on a fortnightly release cycle. And it's really driven that ability to react to those bad experiences as we go forward. One word of warning with this, though, if you're interested in this architecture, it's really easy, as Jill mentioned, to create Lex loops. So you need to be really careful about breakout clauses and thinking about how the customer is going to react. We learned the hard way when we first deployed it that you can trap the customer into a loop that they can't get out of as the child bot passes back to the parent bot, who passes back to the child bot. So the good news is, though, with the data there to support it, you can usually figure that out pretty quickly. So now I'm going to come on to talk about Amazon Q and Connect, if I can get this to work again. There we go. So we wanted to experiment with Q and Connect, and we had a hypothesis that by using the AI, we could support our agents to get to the right outcomes for customers or the right decisions for customers much faster. We wanted to get them to the right action that they could take on behalf of the customer, and we hypothesized that by doing that, we would reduce the AHT for the call, which, as we've said a number of times, is a direct saving that you then feel the next month. But we also hoped that by doing that over time, the NPS for the service would grow because it was a more usable experience for the customer. So we decided to run an experiment. So this is how we've architected our Q and Connect experiment. You've got a customer that's phoning in. While they're on the line with the agent, Q and Connect is listening in the background to everything that the customer is saying. And in real time, is trying to map the current part of the conversation to an intent. And it's important that you understand that it's the current part of the conversation as well. So it's not taking the intent that was picked up when the customer was first passed into the queue. It's recognizing that the intent may change. We quite often see that what the customer thinks they're phoning about turns out to be a different intent to what we had originally envisaged. And actually, sometimes it can be multiple intents, and queue's continually adapting to that. So again, if we take a payment-based example, a customer might phone in because they want to make a payment to a colleague at work to join in on buying a present for someone who's leaving. To them, that's one thing that they want to do, but to us, that's 3 different things. They need to run a balance inquiry to make sure they've got the funds. They need to set up a payee because it's a colleague at work. They've probably not paid them before. And then they need to make the in-payment. So as the journey progresses through, queue's adapting to the advice it's giving based on where it is within the intent journey. It's actually getting this information from Bedrock. So Bedrock's passing back to queue 2 key bits of information. First of all, something the customer can say, the agent can say directly to the customer. So a real phrase they can just read out if they want to. It's then passing them a meaningful description of how to resolve the problem. And it's doing that in a way that allows the agent to understand what the solution is. The other thing that's happening, as you can see down the bottom, is Q and Connect is also making calls to our knowledge repository, which is where the information is coming from in the first place. We call her Ella, but she's the agent's knowledge repository. And at that point, it's pulling back all of the articles that the AI has used to determine with the solution. So they're there for the customer to see if the customer wants to dig deeper into any of those individual solutions. And you can see how that appears on the right. So on the right-hand side, that surfaces directly within the agent's desktop. So you can see in this specific example, the customer is trying to stop their credit card. Perhaps it's been lost or stolen. At the top, Bedrock has provided back to Q something the agent can say directly to the customer. It's provided a meaningful description of how to fix the problem. You go into the MasterCard control panel and you stop the card. It's also highlighted the customer can do that themselves, so they don't have to phone the next time if they want to do it. And down at the bottom, it's got links to all of the articles, which it's storing in an S3 bucket, that now can be queried directly by the agent to figure out what to do next. So how did we run the experiment? That's the architecture. How did we run the experiment? So we ran the experiment initially within our cards business, and we took 10 super agents, as we called them. So 10 agents that under the normal day-to-day would never need to refer to Ella. They've been doing the job for years and they know how to do it. And we asked them to use this and to rate the responses they've got. How accurate were they? Is it what they would have done? Was it useful information? We fed into that 12,000 articles. We fed in both flow and, that's from a list of about 30,000. We fed in both static and flow-based articles, so articles that just gave a simple description of a problem, but also knowledge articles that gave a relatively complicated flow of steps the agent would need to follow. We didn't structure the content in any way, and in order to determine the intent, we fed in the customer side of the conversation to Q. And actually what we saw was 58% intent recognition. A little over half of the intent was correct, which is pretty low. And worse than that, only a third of the time did we actually get the correct answer in terms of what should be done. And the worst bit was that actually the latency problem. So it was really slow to react with that. And the agents were telling us that actually that was a bad experience because the very thing we were trying to do was get there quicker, and instead the agent was waiting to see what the response was that was coming back. So in the true spirit of Agile, we paused for a bit, we had a think, and we ran a second experiment. So the second experiment we ran, we reduced the article numbers from 12,000 down to 1,000, articles that related specifically to the stuff that was in scope for the pilot, rather than a broad scope of articles. We removed the flow-based articles because we started to think that actually our own flow processes were too complicated, so we removed them from that and focused in on the static-based articles. We structured the content to make it easier to search, and we fed in the agent side of the conversation into the intent. And as a result of that, the intent recognition increased slightly. And that was a really interesting point for us. We had completely undervalued the important role that the agent plays in determining what the customer really wants to do versus what they're actually saying, the words that they're actually using. And this got us up to about 50% accuracy on time. But more importantly, it significantly improved the response rate. So now what we're doing is we're assessing what to do next. On the board, you can see some of the examples of the benefits that we've gained from taking this approach and some of the gains that we've made. But actually, the single area we've learned the most about is our own knowledge articles. What we've realized is that to get the best out of Amazon Q, you have to have your articles structured in a way that works with a large language model. And that's likely to be the same for any large language model-based process. So we're going through a process just now of reworking the articles, adding metadata, and stripping out things where, take for example, these articles had often been written by really experienced agents for use by other experienced agents that probably knew the process but needed a reminder. So they used a lot of very business-type speak. They referred to things as this is a process 24, but doesn't tell you what a process 24 is. So it was removing all that stuff and reworking the articles. And we're about to go into our third pilot towards the end of the year, beginning of next year, and we fully expect to see that jump considerably. What I would say is, if anyone else is further along in their Amazon Q journey, we'd really like to talk to you. It's something we see a lot of value in. So if anyone's got beyond this stage with Amazon Q and has some great experiences, please do grab us afterwards, and we'd love to talk to you about what those experiences are. So finally, I'm going to cover off on two things just before we finish that we're looking forward to in particular that are coming in the AI space. So the first one is call summarization. As Jill mentioned, our plan is that customers get through to an agent when they really need us. But the reality is, those conversations where they really need us, they're the really complicated conversations. They're the ones that explore lots of different things, go down different avenues, possibly have lots of actions on the back of them. So our agents spend a lot of time in those conversations in wrap, writing up before they're ready to take another call. So one of the things we're experimenting with just now is after call summarization, where we're looking to let the AI do that for us and actually let the AI engine do the summarization of the call for the agent, save them the time, and all they have to do is read it and validate that it's a fair representation of the call. So this is something we're quite excited about and we're looking forward to experimenting with over the coming months. The other thing we're looking forward to and we've already started to experiment with is Agent Evaluate. So as Jill mentioned, we do 25 million calls a year. It is not possible to analyze all of those calls on an individual level. It's not possible for team leaders to listen to all of the calls that all of their team make to pick up on the learning points or perhaps the things where they're not quite following the process. So with Agent Evaluate, we've started to experiment with creating rules that can then be compared to a call. For example, did the customer ask them questions to probe if they have a vulnerability that they might need additional support with? Or, given that we work in a regulated industry, did the agent say the certain things that they need to say? The value of your investment may go up or down is the joke one that always gets used. So we can start to make sure that these things are happening at a macro level automatically, collate that data, and then the team leaders can have meaningful conversations with the actual agents that need the additional support just to get the service that they're providing just that extra little bit better. So those are the two things that we're particularly looking forward to. Bearing in mind we haven't seen what's coming from reInvent yet, and Chris won't tell us what's coming from reInvent yet. So thank you very much, everybody. Thank you for listening to us today. We hope you've enjoyed that. Hope you've learned something. If you'd like to speak to us afterwards, we'll be available out in the hall. They need to turn the room around, but we'll be available out in the hall afterwards if you wish to have a conversation about anything. On behalf of Jill and I'd like to thank Amazon for having us here today, and in particular, Chris for supporting us. Thank you very much, everybody.